in charge of these decisions. I'm in charge of teaching math, so that's what we should do. Because that's what my job description says. Tiffany Dixon, math teacher. Not Tiffany Dixon, principal. Tiffany Dixon, superintendent. Tiffany Dixon, guidance counselor. I don't make these decisions. I just teach you math. Tiffany Dixon, hater of Nathan. On record. Nope. It could be that Nathan. I didn't just know. Okay, so we've been talking about polynomial functions, and instead of keeping with that, the book says, now let's talk about rational functions, and we'll come back to polynomial functions later, which I find ridiculous, but we're going with it. Because in a minute, or next week, we're going to talk about rational and polynomial inequalities together, so we have to talk about rational functions. This is also something that you did in Algebra 2 and Pre-Cal if you took Pre-Cal, so hopefully maybe not so bad to do. Today we're only focusing on two things. We're not even graphing today. We're just talking about domain and we're talking about asymptotes. And then tomorrow we're not even graphing. And then Monday we'll talk about graphing these. So, you know, baby steps. So here we go. What is a rational function? I always teach my students, even in Algebra 1, that rational has the word ratio in it. And ratio is a fraction. So when you see the word rational function, you should think about it's a fraction of two different polynomial functions. So a rational function is a function in the form r of x equals p of x over q of x, where p and q are polynomial functions. So that's another reason they come after polynomials, because it's just dividing two polynomials. Should drink some coffee. It makes everything seem so much better.
You should really do this. Yeah, you're like wired today.
It's because I didn't sleep. I was up at 11 and 1, and then at 3, Nolan woke up and was coughing and coughed so much that he puked. So then there was puke on my bed and puke on him. So then I had to clean him up, and then he thought it was morning time since he was up and had to get cleaned up. And so then at 3:30, my husband said, I'll just take him downstairs. And then at 4:40, his alarm went off, and he brought him back to me, and he was still awake. And then I got him to sleep, and then 5:20, my alarm goes off, and then I was up. And I said, I think I'm going to drink some coffee today. So I don't think no sleep plus coffee is a good combination, because you think it would be a good combination, but whew.
Eventually. Is that why you sent out the text this morning so you're going to be like,
No, I sent a text out this morning. I almost added it in, not that anyone ever comes in early, but I decided to just leave it at I'm going to be late. And then we stopped at McDonald's to get coffee, which made me later, but it was okay. No, I didn't have any coffee at home. I stopped at McDonald's. Rice. The coffee makes me happy. It's like my treat of not sleeping. Like when I don't drink coffee normally, but when I don't sleep, I think I deserve coffee today. So the domain of a rational function, if you think about that lovely project that we did before Christmas break, which I'm sure you've all forgotten about already, but the rational function that we think of a lot, like the parent function we think of as 1 over x, and if you think about this, the domain, if you have an x in the bottom of your equation, is pretty much never going to be all real numbers. There's an exception to that. Because you can't have 0 in your denominator. So it's really easy to find the domain of this. Maybe not as easy as just always saying all real numbers. But all you have to do is set the denominator equal to 0 and solve it. And that's what your domain can't be. Or maybe your domain, we could say, like, set the denominator not equal to 0. And then that's what x can't be. So when it says find the domain, the top really means nothing in terms of the domain, because the numerator is allowed to be 0, but the denominator isn't. So like half of your homework today is just finding domain. That's good, right? So let's do some. What's wrong, Sawyer? Well, and then we have to talk about asymptotes. Which again is something you've done, but the rules of asymptotes are kind of long, maybe. We still got 32 minutes. So you ready for the 100-day party? Or you don't get to be for the 100-day party. Parker said after special class. But
I leave before they go.
like gym or art or music. Today is the 100th day of school. function. All you have to do is say the domain, I can't have this equal to 0. So I'm going to say x squared minus 5 is not allowed to equal 0. And I'm just going to solve that, and that's going to tell me what x cannot be. X can be any other number except for what makes the denominator equal to 0. And then you just get to practice your awesome algebra skills. So I would add 5 over, I would take the square root, and I would say that x is not allowed to be plus or minus the square root of 5. Yes? Domain, we have to write it in the lovely domain way, which means you have two options. One option is you just do set notation, right? So you just do the little squiggle, x, line, squiggle it.
So why didn't you do that, squiggle?
Because that's the proper notation for domain. It means all x such that x does not equal these numbers. Or the other way is to do it with the parentheses and like the interval stuff with the infinities, which is okay to do, but lots of people don't like to do it when there's more than one. But we could say the domain is negative infinity up to negative radical 5, and then skip negative radical 5 to positive radical 5. I should have like a little u in between those. And then skip radical 5 and go to infinity. Right? That's not very fun, is it?
No.
But I'm okay with it. Like, both of those are proper notation. Just depends on what you like. It seems like this book, it seems like the unit tests, they stress the set notation more than interval notation, and I stress interval notation more than set notation. So this is pretty easy when there's more than one. So what about if I said find the domain of this? This is like the exception to the rule, I think. I don't know, x to the third maybe? It doesn't really matter what it is, but... Thank you, I'm sorry. Yeah, so when we solve this, we get x squared is not allowed to equal negative 1. So x is not allowed to equal plus or minus I. Am I going to say... You're right. You didn't say plus or minus, but...
That would have been half a point on your test, too.
If I'm talking about where x can't be, is I or negative I on my actual graph? No, so we're not going to say that this is my domain, right? If you write out domain and say x cannot equal plus or minus I, I'm going to mark that wrong because that's not real number. So if x is only not allowed to be plus or minus I, what are we going to say our domain is? Yeah, like this is the one time, any time that this can't ever equal 0, is this would have a domain of all real numbers. So I could say that my domain is negative infinity to infinity. If you want to write this in set notation, this is where I think interval notation is better, because you have to say x such that x is a real number. The fancy way to do that is x is an element of the real number system. How about that for some crazy stuff? But probably you would just write x is a real number.
I like that.
I like the little r. It's cool. Makes you... If it's squared, right? What if the bottom just had x minus 5 in it? What would your domain be? X can't equal 5, right? And so sometimes it's not even squared. I just try to do like harder ones for you. Okay. Maybe you had to factor the bottom at some point. I told you we're not graphing today, but I wanted to remind you about asymptotes. And again, this was one of the parent functions that you were supposed to graph on your project before Christmas, except for Nathan didn't do that project, but everyone else did. So maybe he doesn't remember. But he took pre-cal, so he probably remembers, right?
You need to write this down sometimes.
I don't care. I don't make you write any notes down, right? It's your prerogative.
You don't make this, but you imply that you should.
Well, if you ask me for help on your homework and then you don't have notes or it's in it, I might yell at you.
I was saying Mason doesn't take notes, so I don't know since he's really smart.
How about this? In pre-cal yesterday, in second hour, I gave them the unit circle song. Those of you that were in pre-cal might remember that song. Unit circle, unit circle, unit circle all the way. Oh, what fun it is to learn the unit circle in a day. At 0 degrees, the point is 1 and 0. And it's really annoying, but I find it fun to give to them. And so second hour I gave it to them and they laughed and it was funny. And then we found another unit circle song and they were so excited. They're like clapping along and like, hooray, this is great. And they're so happy. And I was like, it was like my happiest day in pre-cal all year because pre-cal's hard. Pre-cal's hard and they hate it most days and they leave frustrated and I'm frustrated. But yesterday was happy. So then sixth hour comes along and I'm like, this will be a good day. I'm gonna let them to the unit circle song. And it was like nothing. Like Noah Taylor's the only one that even smiled. Like I played the unit circle, the first unit circle song. And he smiles, and everyone else, you didn't even smile, Trevor, I'm telling you. It was like nothing. And then the second one comes on, and I'm like, well, they really like this one. And then I like expecting like, hooray. And it was just like I thought Nick Chambers was going to punch me. He looked so mad during the song. And I was like, seriously, like, why do they hate me so much? Trevor's in sixth hour, so he finds this offensive, but it's like daggers. It's like daggers of death coming at me.
Did you not see back there, Bob?
I didn't. Probably because you're in the back and all the mean stares. Like I look out and I see mean stares and I just stop looking. I never get to your smiling face in the back. So. Like I'm out of here. We should be able to look at this and say the domain's never going to equal 0. If you plug 1 in here, you get 1. If you plug 2 in here, you get 1/2. If you plug fractions in here, like 1/2, you get 2. And we should maybe sort of remember that these look like these kind of, I call them L shapes. I don't know, C shapes. I don't know what you call them. If you plug in negative values, you get the same shape, but it's negative, and you get something like this. And rational functions have asymptotes. And remember that asymptotes are a line that your graph gets closer and closer to without ever touching. And so the domain is everything but 0 because no matter what number you plug in here, it's never actually going to get to 0. It's going to get really, really close to it, but it's never going to get there. Oh, that would be this way, right? I mean, it also has a horizontal asymptote. The range is never going to get 0 because you can never get 0 out of this as well. So what we want to do is be able to find our asymptotes without actually having to graph it. Or when we do have to graph it, you want to know the asymptotes ahead of time. So we have vertical asymptotes, we have horizontal asymptotes, and you remember from Algebra 2 that sometimes you also have slant asymptotes? That's maybe the one you don't remember. So you have to know these rules, and probably the horizontal ones are the ones that people struggle with the most, and that's why this is all we're doing today, is domain and asymptotes, and it's a little bit of writing, right? Maybe let's read this before you write it down, all right? Write the word vertical asymptotes, and then let's read this big long sentence before you decide if you want to write it down. This is what the book says about asymptotes, and then I wrote my own little thing here. The book says if a function has a vertical asymptote of x equals r, then x minus r must be a factor of the denominator. Because an asymptote is something that x can't be. So does that kind of make sense? If you had x equals 3 as an asymptote, does it make sense that you'd have to have x minus 3 in your denominator for that to be true? So how do you find vertical asymptotes? Here's what I think you should write down. You can write that whole sentence if you want. But all you have to do to find vertical asymptotes is set your denominator equal to 0 and solve it. And hopefully you see the connection between your domain and your asymptotes. Your domain is what x can't be. Your vertical asymptotes is what x can't be. So if you know your domain, then you know your asymptotes. If you know your asymptotes, then you know your domain. Horizontal asymptotes, not that easy. Horizontal asymptotes, there's rules. It's all about the degree of the numerator and the degree of the denominator. In your book, they talk about limits, and they talk about picking numbers, and getting closer and closer. I'm just going to give you the rule because I don't need to teach you all that. If you took calculus, I'd teach you all that. But it's not important for you. Here you go. You got to write this down. There's no shorthanding it. Rachel, how was your shot? They give you a sticker? No.
No, they told me, they're like, well, you should probably get 2 more. And I'm like, oh, that's fine. I'm not gonna grab. So. I always still text her because I'm like, I don't follow. It says please take 1, but I like them all. And they always have new ones.
So I'm calling, for our rules here, I'm calling the degree of the numerator n and the degree of the denominator d. So in my rules here, you're going to see n and d, n being the degree of the numerator, d being the degree of the denominator. So there are options here. The first option is if the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote will always be the line y equals 0, like 1 over x. The degree of the numerator is nothing, the degree of the denominator is 1, so that's why the x-axis is a horizontal asymptote. Your book says this is a proper rational function. If it's proper, then it's y equals 0. What? That's nonsense.
I don't
As opposed to an improper rational function.
Yeah, how
So-
do we go from what we were doing yesterday to this?
Because this is rational function. This is why college algebra is difficult. Imagine if we were going at the speed of a normal college class. We would have done
Fill out.
5-1, like they do 5-1 and 5-2 in the same day. It's like, so everything we've done this week, plus this, would have all been in one day class.
Yeah, those are things.
But this isn't because we're not doing it in a short period of time.
So we're smart for taking it now.
You are smart with it. What else could happen? This is, I think, the weirdest one to write out. But if the numerator and the denominator have the same degree, and we're going to do examples of this, but if the numerator and the denominator have the same degree, then your asymptote is whatever the leading coefficients are. So it really could be anything. So whatever the leading coefficients are becomes your asymptote. So I wrote y equals leading coefficient over leading coefficient, because you have to take the leading coefficient of the numerator over the leading coefficient of the denominator. So if the numerator is less than the denominator, you have this. If the numerator equals the denominator, you have this. What's the third option? What else can happen? If the numerator is bigger than the denominator, there will never be a horizontal asymptote. So there will be no horizontal asymptote. Yes, sir. Not necessarily. Like, let's say I had the equation y equals x squared plus 7 over 3x squared minus 6. So if the degrees are the same, right, you have to take the numbers in front. So like in this example, your horizontal asymptote would be 1 over 3 or 1/3. Does that make sense? Right, like it's the same thing over the same thing, right? But that's why it's weird to write that one out. I could make it way uglier to write out, but I decided to write like that, and we do an example. So part of your homework today is domain, and the other part is writing all the asymptotes. So this is vertical and horizontal, but there's one other type of asymptote. If there's no horizontal asymptote, if the numerator is bigger than the denominator, then we could have a slant asymptote, or your book calls it an oblique asymptote.
I remember this. I really hated it.
So if no horizontal asymptote, or maybe you could put if the numerator is greater than the denominator, because that's when there's no horizontal asymptote, then it is an oblique, or if you remember from Algebra 2 or pre-calculus, we call that a slant asymptote, but this book calls it an oblique. And to find it, you have to do long or synthetic division. You remember how to do that, right?
Oh, I remember why I hated this.
And you might say, well, why would you do long division when you could do synthetic division? But you can only do synthetic division sometimes, and so I'm going to show you why you might have to do long division. I know, we're going to...
Is that what this is like? Like this little box?
Synthetic division is where you do a little box, yes. But you can only do synthetic division if you're dividing by something like x minus one number. You can't do synthetic division if it's like x squared minus something. So that's why we're going to do this then. So let's do this first example here. Or I guess fourth example, but you know. Is this number 4 or number 3? I think it should be number 3.
Oh, well, the graph.
Oh, there you go. Okay. I was going to throw something else in this, and then after I wrote these notes out yesterday. I decided let's just stop at asymptotes. Well, sometimes you have an asymptote, and sometimes you have a hole in your graph. And I didn't talk about holes today. I'm talking about holes tomorrow. Because you got to know the difference between an asymptote and a hole in your graph. So, you don't have to label these vertical, horizontal, or slant because the way you write them tells you if they're vertical, horizontal, or slant. But I'm going to write those words just so you can see it in your notes. But vertical asymptotes will always be x equals a number, horizontal is always y equals a number, and slant asymptotes is going to have an x in it. So that's how you know the difference. So just know you don't have to label them. But just to show you here, vertical asymptotes, all you do is you set the denominator equal to 0. What in the heck kind of problem is this?
You did.
Yeah.
Good job.
I just wrote it wrong, Sawyer. Good grief. I don't know why I even talked about it. I don't know why. I can't even brag about my students because I'm...
You can't brag to other students about your students. That's what the teachers are on this for.
It was that kid that did it to me.
You don't talk bad about the other students.
Let's change this to find horizontal / oblique asymptotes. Forget about the vertical one here. Alright. Because we can't set that equal to 0 yet. We don't know how to do that yet. I love you all. I love this class. I got a whole bucket of dum-dum suckers in my... Oh, sorry, that makes me laugh a lot. Because it's dum-dum sucker, get it?
So unnecessary.
She's calling us a dumb.
When I was in college, one of my math professors, if she ever gave you dum-dum suckers, she gave you Smarties. Because she said you had to counteract it, like you couldn't give a dum-dum sucker unless you took Smarties at the same time to balance it out. And like just one of those little suckers. Like my brother-in-law and his girlfriend at Christmas brought this like 5-gallon bucket of dum-dum suckers and said, "Here, take this home to Parker." And I said, "I'm not giving Parker a 5-gallon bucket of dum-dum suckers." She's like, "Well, I tried to give it to someone for a birthday present, but their parents said no." And I was like, "So you give them to me?" She's like, "Yep, you take them home." So they've been in my car since Christmas, probably.
Why didn't they just
Why don't you just bring them in here?
Because I kept telling myself I was going to take them to the haircut place because they always give dum-dum suckers as a little thing, and I was just going to take them where I get my haircut and give them to them. But
Yeah, but it's like that.
they give them to kids. They get their haircut.
No.
So what about this? What's the degree of the numerator? 4. What's the degree of the denominator? So do you agree that I would say the numerator is bigger than the denominator on this?
Yes.
So that means there is no horizontal asymptote because the numerator is bigger than the denominator. Yes? So if there's no horizontal asymptote, that means there is an oblique asymptote. And to do it, you actually divide this, right? Like this says 3x to the 4th minus x squared divided by x cubed minus x squared plus 1. Yes? So we're actually going to divide it. So we're going to, the top number goes under the little thing, we're going to do 3x to the 4th. And do you remember when you do division, you have to fill the zeros in? Well, you do. So we're going to say plus 0x to the 3rd minus x squared. And you got to fill in all the zeros down to a constant. So I have to say plus 0x plus 0. And then what's on the bottom, you also have to fill zeros in if there's anything missing. And you get x cubed minus x squared plus 0x plus 1. You only start with whatever's there. Like I only fill in what's starting with the first one and filling in what's missing. Does that make sense? And And what we're going to do is just like long division with numbers, which I know you don't do anymore because you have calculators, but you know the process. If I asked you to divide 7 into 461, you would say 7 doesn't go into 4, and how many times does 7 go into 46? And you would be like, oh, 6 times, and you would multiply and subtract and keep going. We do the same thing with this. Look at this first part, and look at this, and you kind of say, what do I multiply x cubed by to get 3x to the 4th? The answer would be 3x, right? And this seems like a really long problem, but there's a bunch of stuff to multiply, so it's not really that bad. But watch your signs here. We're going to take, just like here, we would take 6 times 7 and get 42. We're going to take 3x times everything here, and that's why you have to fill your zeros in, so everything will line up. So 3x times x cubed is 3x to the 4th. 3x times negative x squared is negative 3x to the 3rd. 3x times 0x is 0x squared. And 3x times 1 is 3x. If your exponents don't line up, it just means you forgot to fill 0 in. And then you can just be like, why doesn't that line up? Oh, I got to fill 0 in. And then remember, when you do division, you subtract. So when you do this, you subtract. I don't care how you do it. I like to distribute my subtraction sign because otherwise I mess up my subtraction. So when I do this, I'm going to go through and subtract everything. So that's going to be minus. That minus is going to change to plus. That's going to be minus, and that's going to be minus. And it helps me keep track of my negative sign. If you don't do that, that's okay. But I can tell you the number one mistake that people make on long division is subtraction. That cancels out. 0 plus 3x cubed is 3x cubed. That's minus 0, so that's just minus x squared minus 3x. Is it coming back to you? And then remember what you do next. You bring down the next number till there's nothing to bring down, and you repeat the process. So the good thing about this is we only have one thing to bring down, which means this is our last step. And we're going to just repeat the process. Now you'd say, how many times does 7 go into 41? Or we say, what do we multiply x cubed by to get 3x cubed? And it's just 3. And we would do this all again, and you remember you get a remainder, right? Here's the great thing about slant asymptotes. The remainder means nothing. So we could do this all, and we could line it all up, but do you agree what we get now is our remainder? I don't care about the remainder. The remainder means nothing. Your slant asymptote is what you get minus your remainder. So you don't really have to keep going. Do you want me to keep going?
No.
So I'm just going to say this doesn't matter. My slant asymptote is the line y equals 3x plus 3. A slant or an oblique asymptote is always a linear line, like it has slope. So it'll always be y equals something x when you do this. What I have up here. This is your oblique asymptote. And you don't do anything with the remainder. So that's what's nice about it is you don't have to keep going once you know your 2-year remainder. And your 2-year remainder when you have nothing else to bring down.
So I thought that was right down at the last equals 0.
That's if your remainder is 0, right? This is going to have some remainder. It's going to be ugly, but the remainder means nothing for the asymptote. The remainder means something in other terms, but not for the asymptote. Sorry, go. Yes, you only look at the first thing, and then you multiply everything by it. Let's do another one. They're not going to all be slant asymptotes. I don't think any other ones are, but I don't know. Well, at least let's try to do 2 more, even if I have more than that. You can only do synthetic if the bottom is not squared. So we'll see if I don't even know if there's anything like that in homework, so we'll get there. If you remember synthetic, you can try it, but I think I don't have time to show that today. We're having homework. You just actually have to do it as homework. Vertical asymptotes. If I said x squared plus 1 equals 0, what happens? I get imaginary again, right? So what does that mean? The domains are real numbers, so what's that mean for my asymptote? Is there a vertical asymptote? No. So if this doesn't equal 0, if it's imaginary, we can say there is no vertical asymptote. What about horizontal? Like on this one, what is the degree of the numerator compared to the degree of the denominator? It's the same. They're both 2's, right? So I'm going to write that over here. Numerator equals denominator. And right now, look at your notes to see those rules. But by the time we have a quiz or a test, you have to know when the numerator equals the denominator, your asymptote is the equation y equals the leading coefficients. And so Nathan, on this one, it does work out that the leading coefficients are both 1, so you just get 1 over 1. If the numerator is equal to the denominator, is there going to be a slant asymptote? No, so that's great. The only time there's a slant asymptote is if the numerator is bigger than the denominator. So they're not all as bad as the one we just did, right? Let's do it. I don't even know what happened. Oh, I do. Let's do vertical first. So I find vertical asymptotes. Set the denominator equal to 0. And I get that there's 2 vertical asymptotes at 2 and negative 2. Yes? Vertical asymptotes do equal it. The only time you put not equal to is if we're talking about domain. Vertical asymptote is the line that it never touches. Horizontal. Degree of the numerator is 1. Degree of the denominator is 2. So do you agree that this is when the numerator is less than the denominator? And what is the horizontal asymptote if the numerator is less than the denominator? Just y equals 0. Like, you just have to know those rules. Is there going to be a slant asymptote? No, because it's not greater than. So not all, like, I wanted to do the division one first, just to remind you about division, but you don't have to do that unless there's a slant asymptote. You don't have to write this down. I just wanted to, like, tell you this. It's in your book. But for vertical asymptotes, there could be no vertical asymptote, because it could be imaginary. There could be 1 vertical asymptote, or there could be more than 1. There could be 2, there could be 4, there could be 6 technically, but usually it's just 2. Horizontal asymptote, there could be no horizontal asymptote, or there could be 1. You can never have more than 1 horizontal asymptote, because look at the rules, it doesn't work for that. And the same thing with the slant asymptote. There could be none, or there could be 1. Vertical asymptotes are the only ones that can be more than 1. So my question is, could you ever have a graph that has both a oblique and a horizontal asymptote at the same time? Doesn't work, right? Oblique has to be when the numerator is bigger than the denominator, and if that's true, there's always no horizontal asymptote. So you'll never have a graph that has both a slant and a horizontal, because they can't happen at the same time. Vertical and any of those other ones can happen, but slant and horizontal, it's one or the other. Okay? Are you writing that down? This is 5-2 day 1. There's no graphing on this. I think 15 through 24, 15, 18, 21, 24. 4 problems, it's just domain. And then 43, 46, and 48 just say find the asymptotes. So it's not that bad, but important stuff. Because tomorrow I'm going to add on to what's the difference between the asymptote and the hole. And go from there. And then we're going to graph using this. So that's 5-3 is graphing these.